Why does a phone have no signal? If we encounter this issue with our phone, how do we identify the root cause? The iPhone 14 Plus is different from earlier models. It's disassembled starting from the back cover. So here's a question. Do you know which other iPhone models also open from the back? Doesn't it feel a bit like the iPhone 4S or iPhone 4? We open the back cover, and we can clearly see this phone has been repaired before. The motherboard is extremely dirty, the back cover is damaged, and the rear camera's blue coating is very dirty too. How do we deal with a dirty blue lens like this? First, we protect it. Let's go ahead and remove the back cover, disconnect the battery, disconnect the flex cables connected to the back panel, and now we can remove the back cover. We find that the metal shield was not installed properly either. If the baseband is not functioning normally, or if there's an issue with it, it's almost always caused by the motherboard. Since the motherboard has been previously repaired, we need to remove it, disconnect the flex cable for the Face ID module, remove the front camera and Face ID unit, and set it aside for protection. Now we unscrew the remaining screws. This flex cable includes the earpiece and Wi-Fi antenna. We remove it. Next, remove the large screws securing the motherboard. We tilt the motherboard up, and once opened, we notice the black stickers, foam pads, and metal shields for the display and touch cables are all missing. We disconnect the sensor cable and display/touch cable and remove the motherboard. Upon inspection, the top stickers and foam on the connectors are gone, and the entire board is extremely dirty because there's no baseband and the motherboard is faulty. We'll power the board up to see if there's any short circuit or leakage. If it leaks current, our repair direction will focus on power supply troubleshooting. After testing the boot current is normal, since it's already been worked on, we'll go ahead and separate the layers of the board. Quick question for you, what phone are you using now, and what's the issue? Once the solder between the layers melts, we separate the two halves. You'll see the CPU is in the upper middle, but this model's logic board has chips on all four sides, so there's no real front or back. The RF board, responsible for signal, is incredibly thin. It primarily handles Wi-Fi and baseband. Under the microscope, we inspect closely. We find not just a layered board, but clear signs of previous repair to the signal section. However, the baseband and Wi-Fi chips appear untouched. What has been worked on are the RF power amplifiers and antenna switches. This isn't a simple issue. This is a common iPhone fault, often due to faulty antenna switches. We can see they've already been reinstalled or replaced. We start by cleaning the board. Although this is an iPhone 14 Plus, it uses the A15 chip, same as the iPhone 13 Pro. Its baseband chip is Qualcomm X65. We place the RF board into a clamp, secure it, and inspect the antenna switches for loose solder joints or pad damage. Since all these antenna chips have already been replaced, we must remove them again to examine the pads underneath, because the signal system involves many chips, including RF amps, 5G switches, high/low band antennas, and this board is so thin, it's likely been overheated several times already. So instead of further risky rework, we opt to replace the entire RF board. We will transfer the encrypted chips, Wi-Fi and baseband chips from the damaged board to a clean donor. We begin by removing the Wi-Fi chip, then the baseband chip. Now we clean the old solder pads because we need to extract the encryption data from a small chip under the baseband, called the baseband code chip. Using a reader, we pull the encrypted data from the original board and save it. We take the cleaned replacement RF board with its pads pre-polished and write the saved code chip data into it. Once that's done, we flatten and prep the Wi-Fi chip's pads, then the baseband chip's pads. Next, we apply solder balls to both chips, cleaning thoroughly and applying flux. We align and reflow the chips onto the new RF board. The Wi-Fi chip goes first, then the baseband chip, which has smaller solder points and requires even more delicate handling. After soldering, we clean the board again, apply flux to both top and bottom pads, and ensure a smooth finish. This helps with final board reassembly. Once clean, we turn to the logic board, CPU layer, inspect and clean it thoroughly as well. We now place the logic board on the reballing platform, apply solder paste, and reflow the solder. Afterwards, we apply flux on the RF board's pads, add thermal paste to the A15 chip, then align and place both layers together. We turn on the heater, and once we feel a springy bounce, the QQ pop, we know soldering is complete. Once cooled, we remove the board, power it up, and the boot current is normal. We clean all sides of the board, reapply missing stickers and foam for thermal protection. Now the motherboard looks much better. We clean out the phone casing, install the motherboard, reconnect the display and sensor cables, replace missing shields and screws. Reminder, if your phone suddenly has no signal, step 1 is to restart the phone. If that fails, try another SIM card. If it still doesn't work, don't rush to reinstall the system if the baseband is faulty. You'll be stuck at activation, unable to complete setup. If SIM and system aren't the issue, it's very likely a motherboard fault. Software-caused signal problems are rare. You can also dial *#06# to check if the IMEI appears. If it doesn't, that's usually a baseband or board issue. We now clean the rear camera's blue coating with a special lens cleaner. It looks fine now, but if it had scratches, there's no way to fix that. Signal involves many parts: baseband, RF amps, split into frequency. Bands. Antenna switches, high/low band antennas. So it's very hard to troubleshoot. In fact, signal problems are among the hardest to repair. With a board this thin, too much heating and soldering can weaken traces and cause instability. So in today's repair, we chose to replace the RF board entirely to fix the signal fault. But if the baseband chip itself is dead, replacing the RF board won't help. Only when the baseband's working and signal paths are intact can we achieve a full repair. And remember, baseband chips are encrypted. After final assembly, we place the phone in a pressure tool for curing. Once done, we screw in the bottom screws. We power on using a cable that shows charging current. Boot successful. We enter the lock screen. Wi-Fi works, and cellular says no SIM card instead of no service, a good sign. Under About, we see both Wi-Fi MAC address and modem firmware. We dial *#06 #IMEI appears. Great. Now we insert a SIM card and signal is restored. Calls work fine. Dear customer, all operators are currently busy. Automated call response test successful. We test every function thoroughly before finishing. And just look at this RF board, how incredibly thin it is. We don't ship the phone back immediately. It needs 2 more days of stability testing. We apply a screen protector for the fan. Thanks to all of you for your support. If you like this kind of repair content, double tap the screen. And don't forget to follow me if you haven't yet.